Welcome to our journey through the amazing world of chemistry. Get ready to explore the building blocks of our universe, atoms and molecules. Today we're diving into the different types of chemical reactions. These reactions are happening all around us, from the food we eat to the air we breathe. So buckle up, science fans, and get ready for an explosive adventure. Let's start with synthesis reactions. Imagine you're putting together a puzzle. You take two or more separate pieces and combine them to create something new. That's essentially what happens in a synthesis reaction. Atoms and molecules, our tiny building blocks, come together to form a more complex structure. It's like taking the ingredients of a cake, flour, sugar, eggs, and baking them together to create a delicious treat. One example of a synthesis reaction is the formation of water. We all know water is H2O. Two hydrogen molecules react with one oxygen molecule and voila, we get water. Another example, photosynthesis. Plants use sunlight, carbon dioxide, and water to create glucose, their source of energy. It's a vital synthesis reaction that sustains life on Earth. Synthesis reactions are all about building and creating just like we do every day. Now let's flip the script and talk about decomposition reactions. If synthesis is like putting a puzzle together, decomposition is like taking it apart. We're breaking down a complex molecule into simpler substances. Think of it like dismantling a Lego structure. You start with a complete build, then carefully take it apart piece by piece. That's decomposition in action. One example is the electrolysis of water. By passing an electric current through water, we can break it down into its components, hydrogen and oxygen gas. It's like reversing the formation of water. Decomposition reactions are essential in many industrial processes. For instance, the breakdown of limestone at high temperatures produces lime, a crucial component in cement production. So remember, while synthesis builds, decomposition breaks down, and both are equally important in the grand scheme of chemistry. Hold on to your lab coats because things are about to get a little more interesting with single replacement reactions. Imagine a dance floor with couples switching partners. That's the basic idea here. A more reactive element swoops in and replaces a less reactive element in a compound. It's like a chemical game of musical chairs. One classic example, dropping a zinc metal strip into a copper sulfate solution. Zinc, being more reactive, displaces copper, forming zinc sulfate and leaving behind copper metal. You'll see a color change and maybe even some copper depositing on the zinc strip. It's chemistry in action. These reactions are used in various applications like extracting metals from their ores. It's a bit like a chemical heist where one element steals the spotlight. Get ready for a double feature because we're talking about double replacement reactions. This time, two compounds get in on the action, swapping their positive and negative ions. Think of it like two sets of dancers switching partners. It's a bit more complex, but the principle is the same. One common example is the reaction between silver nitrate and sodium chloride, or table salt. When these two solutions mix, the positive silver ions pair up with the negative chloride ions, forming silver chloride, a white precipitate. The sodium and nitrate ions also switch places, but they remain dissolved in the solution. This type of reaction is widely used in analytical chemistry to identify unknown substances. It's like a chemical detective using clues to solve a mystery. Let's turn up the heat and talk about combustion reactions. These reactions involve the rapid reaction between a substance with an oxidant, usually oxygen, to produce heat and light. In other words, things burn. Think about lighting a candle. The wax in the candle reacts with oxygen in the air, producing a flame that gives off heat and light. Without combustion, we wouldn't have fire, which is essential for so many things. Combustion is the driving force behind internal combustion engines found in cars and other vehicles. Gasoline or diesel fuel combusts with oxygen, releasing energy that powers the engine. It's a powerful reaction that keeps us moving. But remember, fire can be dangerous if not handled properly. Always be careful around open flames and make sure to have a fire extinguisher nearby, just in case. Thanks for joining us on this chemical adventure. We've explored the fascinating world of chemical reactions, from the building blocks of synthesis to the fiery power of combustion. Remember, chemistry is happening all around us every minute of every day. So keep your eyes peeled and your minds curious, because there's always something new to discover in the amazing world of science. Don't forget to like, subscribe, and hit the bell icon for more exciting science content.